Hey guys, welcome back to another video. This is the last video for the series of electric fields for A2 level physics. In this video, we're going to talk about the motion of charged particles between charged plates. Therefore, motion of charged particles under the influence of uniform fields. So this topic is a bit short, so yeah. Over here, you'll see that there are two oppositely charged plates, positively charged, negatively charged, right? Now, in between these two plates, granted they're charged equally, the electric field lines are going to be equally spread out, meaning the field lines are uniform. The field lines are uniform. Notice the field lines are equally distributed since the charges on the plate, both the plates are equally distributed as well. So, if the field lines are equally distributed due to the charge being equally distributed on either plate, you will see uniform field lines. Now, under these circumstances, if you have, let's say, a positive charge of any amount, let's say you release it from over here, and what you're going to see as it passes through this space between the plates, it's going to feel an electric force due to these electric field lines, due to the field lines between the plates. Now, notice the trajectory of the charge is a parabola. It is a parabola. Why is it a parabola? Because throughout this journey, let's say it travels x meters, or let's say 10 meters. At every single point, it will face or feel the same amount of force. Whatever the electric field strength is, let's say the electric field strength is 2 newtons times this charge, let's say it has a charge of 1 coulomb, the total force felt by the charge is going to be 2 newtons throughout the journey. So, let's say if you release this positive charge with, let's say, 4 meter per second of speed, what you're going to notice is it is going to travel in this direction. It is going to travel in this direction with the same speed, but it will accelerate downwards. The speed that is horizontal to the charge is not going to change. It will only affect the vertical component, that is in this direction. So, this charge continues to move at a speed of 4 meters per second even at this position. However, due to the vertical force, that is, let's say, 2 newtons of force, it is going to accelerate downwards. And due to that constant force, you're going to see that the charge is going to be attracted towards this negatively charged plate, due to the repulsion of the positively charged plate and due to the attraction of the negatively charged plate, resulting in a net force. Now, notice this is a parabola, and this is due to a constant force downwards that results in a parabola. Remember, in projectile motion, when you've probably learned it in mechanics or in AS physics, that when an object is released with a let's say with any horizontal speed, and if you release it under the influence of gravity, what you're going to notice is its horizontal speed remains the same, however it accelerates downwards. That results in a parabola. We see the same thing happening over here when you release a positive charge with any amount of velocity in the horizontal direction. That velocity remains same, but due to the constant force at every given position of 2 newtons, its speed vertically downwards increases due to the force. So it accelerates downwards. That results in the parabola. Okay. In case of magnetic fields, which you will learn in the next chapters, in that case, the charges will often go through a different trajectory. That is under the influence of magnetic fields, and that is going to be giving a shape of an arc. That is a part of a circle. So, in that case, remember, the shape is the trajectory of the charge is an arc, not a parabola. In case of electric fields, due to the constant force, it's going to be a parabola. Due to the constant force in the same direction in electric fields, it's a parabola. And in case of magnetic fields, what happens is the direction of force changes. You will learn about it in the topic about magnetic fields. And since the direction of force changes, your trajectory of the charge becomes an arc, not a parabola. So in that case, the route taken by the charge is different. In this case, the trajectory is going to be different. In case of a negative charge, if you notice, if released with any horizontal velocity, it's going to have a trajectory similar to a parabola. That is, it's going to be attracted towards the positive plate, since repelled by the negative plate and attracted by the positive plate. Now, this shape of the parabola is going to be influenced by a few factors. Okay, what are the factors? The amount of deflection depends on the following properties. That is, your deflection would be less if your mass is higher. Therefore, deflection is inversely proportional to mass. Why? When your, let's say, charged object has a higher mass, it will tend to resist the force. It will tend to resist the force even more due to its increased mass due to inertia. It will tend to resist the force, which is why the deflection will be less. So if you have a lower mass, it will deflect more. It will deflect more. Okay? Great. So the next point is charge. If you have a higher or a larger charge, you're going to see an increased deflection or a larger deflection due to increased attractive properties and increased repulsive properties. If there is a negative charge with increased charge, it's going to be repelled even more and attracted even more by the positive charge. So that's your second point. Third and last point is the speed. The speed at which your charge is traveling. If the speed is larger, the influence due to the force will be lower. The influence due to the force will be lower. Why? Because this charge will be spending less amount of time between the charged plates. It will spend less amount of time between the charged plates, which is why the force will be unable to exert or push it as much as the previous cases where the speed was lower. The speed increases, the charge spends less amount of time, so the force gets to do less work on the charge and push it towards either of the plate, right? So if the speed is increased, your deflection you will see is lower. So those are the three factors that affect the deflection and the trajectory of your charge between uniform fields. Remember, in case of uniform fields, the force does not change. The force remains constant throughout the region between the plates. And the force in this position near the positive plate is going to be the same as the position near the negatively charged plates due to uniform field lines. That is what we mean by uniform field lines, that the force is, or the electric field strength is equal at every given position. Okay, that's it for electric fields there. And that is the end to the series.